Number 17. Given that P, Q, and R are primes, such that PQ plus QR plus RP equals 48, how many possible ordered triplets PQR are there? To solve this problem, let's use parity, which is the property of whether integers are even or odd. So all primes except for 2 are odd. Let's first consider the situation where PQR are all odd. Then that would make PQ odd, since an odd times an odd is also an odd, QR odd, and RP also odd. However, if all three of these are odd, then that means that their sum must also be odd, but their sum is 48. So that means it's not possible for P, Q, and R to all be odd. Now let's try a different scenario, which is if P is even, but Q and R are both odd. We can say that P is even without loss of generality. In this case, then PQ would be even, PR would be even, and QR would be odd. So let's test this out. Unfortunately, this means that if PQ is even, QR is odd, and RP is even, their sum would be odd, but 48 is even. So that means it's not possible if only one is even. Now let's try the case where two of the numbers, PQR, are even. So without loss of generality, let's say that P is even, Q is even, and R is odd. In this case, PQ would be even, QR would be even, and and PR would also be even. So that means that all three of these numbers are even, which adds up to 48, which is an even number. Thus, we've shown that it's a possibility that all three numbers, P, Q, and R, of these three numbers, 2 are even. Now let's consider the final possibility, which is that all three numbers are even. In this case, PQ, QR, and PR would all also be even, so they would fit 48. So this is also a possibility. Now, let's go into more detail. If one of the primes PQR is even, then that prime must be equal to 2, since 2 is the only prime. So, if P and Q are both equal to 2, then R must be some other prime. So let's figure out what value R must be in order for PQ plus QR plus RP to be equal to 48. Since P and Q are both 2, we can substitute that in here. So then that means that 4R is equal to 44, and R is equal to 11. Therefore, one possibility for PQR is if 2 of the numbers are 2, and the third number is 11. This is a possibility because all three of these numbers are primes. Now let's go check the scenario where all three numbers are even. In this case, since the numbers have to be even and prime, there's only one option, which is that all of the numbers are 2. In this case, P, Q, and R would also be equal to 2. But then, PQ plus QR plus RP would be equal to 12 and not 48. So therefore, it's not possible for all three primes to be even. So thus we found that this is our only possibility. The answer asks for how many possible ordered triplets. So we find that there are 3 possible ordered triplets for PQR, as shown over here. Thus, our answer is 3.